Hey guys, in this video we're going to talk about the quadratic formula. So this is a way of solving quadratic equations when we don't have something that is factorable. So we can't factor. We could complete the square and solve that way. That's always an option. But this way is, well, most people consider it easier. So we are going to talk about this. So let's, first thing we have to do when we're doing this is we have to get so that one side equals 0. So I'm going to subtract the 7x squared to the other side. So I've got negative 7x squared plus 7x plus 9. And I rearranged the other two terms so that we have it in the order that we're familiar with. So this order is going to be really important for quadratic formula. So just like we're doing refactoring, we're going to have this is going to be A, this is going to be B, and this is going to be C. And that's going to be really important for the quadratic formula. So the standard form of a quadratic equation is ax squared plus bx plus c. And this is going to have to equal 0. So the quadratic formula goes like this. X equals negative b plus or minus the square root, this is a plus or minus, of b squared minus 4ac over 2a. Probably like, wow, that's a lot. Do I need to memorize that? Eventually, yes. But right now, not necessarily. However, to help you memorize or remember this formula, there's a song. There are actually several songs, but this is the one that is probably the catchiest. It's to the tune of Pop Goes the Weasel. And if you want to hear a better rendition than just me singing it, you can search on YouTube, quadratic formula, Pop Goes the Weasel. Anyway, it goes like this. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you sing that to yourself in your head while you're trying to remember this formula, it's really helpful. So let's do it again. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So I encourage you to watch a YouTube video with a better rendition of that than just me singing a cappella. But hopefully you'll find that helpful. Okay, so let's see how we actually use this thing. So this A, B, and C corresponds to this A, B, and C. So I can take negative 7 is A, 7 is B, and 9 is C. So that's how I'm going to plug it in here. So if it helps, you can write A, B, C to help you remember. And we're going to plug them into our formula. So we have X equals negative B. Well, B is 7, so negative B is negative 7 plus or minus, because remember we have two answers to any quadratic equation, so we need a plus or minus, the square root of b squared, so 7 squared, minus 4 times a, which is negative 7, times c, which is 9. Pull this out a little longer. All divided by 2 times a, which is negative 7. So we're just taking these numbers and we're plugging them into this formula. So let's simplify. So we're going to have x equals negative 7 plus or minus the square root. 7 squared is 49 minus Actually, it's going to end up being plus, but talk about that as we get there. Negative 4 times negative 7 times 9. So negative 4 times negative 7 times 9 is 252. So since we had two negatives, it becomes positive. So this is positive 252. All over 2 times negative 7 is negative 14. 49 plus 252 is 301. So x equals negative 7 plus or minus the square root of 301 over negative 14. And you should recognize that as being this answer. We could do some simplifying. We could split it up into two fractions and simplify. We don't need to because this is clearly the answer. But say this wasn't there, and instead we had an option that looked like this. Oops. This would also be accurate because I split this into two fractions, so negative 7 over negative 14 plus or minus 301, square root of 301 over negative 14, and then simplified this one to, oops, it's not 107, it's 102, 1 over 2, sorry. This is 1 over 2, sorry about that. So I simplified this to 1 over 2, and then this one stays the same. So you're allowed to split the fraction. So if they don't have one that looks like this, it might look like this. Alternatively, you might have to simplify your radical. Square root of 301, I don't think simplifies at all, which is why it doesn't have a simplified version there. But this, for example, is the simplified version of the square root of 24. So if you got square root of 24, that would be the same thing as this. So you might have to simplify your square root. You might even have to completely solve. This is what would happen if you had something under the square root that actually that was actually a perfect square, right? Because there are no square roots in this answer, which means the square root went away, which means what was under it must have been a perfect square, which means that this was factorable to begin with, but that doesn't really matter. You can use the quadratic formula whether this is factorable or not. Usually people consider it faster or easier to factor than to use this big formula. But this formula will always work. There are two ways to solve quadratics that always work. One is the quadratic formula and one is completing the square. Most people don't like completing the square, so they tend to use the quadratic formula. Yeah. I want to solve the same one by completing the square really quick just to show you what that would look like. So we already know that D is our answer. So I'm going to go ahead and erase all of this. We will do another example. I just want to show you the completing the square version really quickly, hopefully. So to complete the square, I would factor out the 7 out of the first two, and I would leave 9 off by itself. So negative 7 x squared plus 1, leave a space, plus 9. So I'm going to get negative 7 x plus 1/2 squared. Remember, you divide by 2 here. And then, so I would get 1/4 means I would add 7/4. We add because this is negative, so I subtracted 1/4 times 7. So -7 times 1/4 is -7/4. So I have a -7/4, so I have to add 7/4 here because I have to do the opposite of what I did. Whatever I did here, I have to do the opposite here. So usually that means subtracting over here. In this case, since this one was negative, I have to add over here. Okay, so 9 plus 7/4. 9 times 4 is 36 plus, so I have 36/4 plus 7/4 is 43/4. So plus 43/4. So this equals 0. Then I can subtract 43/4 from both sides. So at this point, it becomes a solve by taking the square root problem like we did at the beginning of this unit. So I'm going to multiply by -1/7 because that will cancel. And then I don't have to deal with compound fractions. So I get positive 43 over 4 times 7 is 28. So now that I have the squared thing by itself, I can take the square root of both sides. So I have x plus 1/2 equals plus or minus the square root of 43 over 28. And then I would just subtract 1/2. So x equals -1/2 plus or minus square root of 43 over 28. Yeah. So this obviously doesn't look like this. But if you did the simplification, you would get the same thing. It's just going to look different. So for example, if I did the plus version, I would get -7 plus the square root of 301. Get a number for that, divide that by -14, and I would get negative 0.74. And then if I did this one, I would get -1/2 square root of 43 over 28. Type it into the calculator correctly. And I get the same thing. Nope. I did make one little mistake. And that was right here. I made a mistake. This should have been negative. I factored out a negative, so that sign should have changed. And I didn't change that sign. So this should be negative all the way through, which means that when I And when I get here, instead of subtracting it from both sides, I'm adding it from both sides. So this is positive. Now I get the same thing. So if I put that in a calculator, the positive version would give me this. This is just the positive version. Remember, there are two. There's the where we have a plus here, and then there's the one where we have the minus. And same here. So these look different, but they give you the same answers. So all of that to say that you can either use the quadratic formula or complete the square. They both work. So let's go ahead and check our answer and go on to the next one. Okay. All right. So let's do one more example of using the quadratic formula. So to do this, we are going to get this side to equal 0 first, and we're going to get this in the order that we're used to, this order. Remember, it has to be this order because A is the one that goes with x squared, B is the one that goes with x, C is the one by itself. So we're going to have negative 9x squared. We're going to add 16 to both sides while we're doing this. Add 16 to both sides. So negative 9x squared plus 3x plus 10, right? Negative 6 plus 16 is 10, equals 0. And now that we have it in this form with something that equals 0, now we can use quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. It's really hard to stay in tune when you're writing and singing at the same time. Okay, so we're going to use this as A, B, C, and we're going to plug those into the formula. So x squared, no, just x equals negative b is going to be negative 3, right? If this is negative, by the way, so say this had been minus 3, then this would be positive. So it's just the opposite sign of whatever is here. Plus or minus b squared, so 3 squared, minus 4 times negative 9, that's A, times C is 10, over 2 times negative 9. So simplifying this, we get x equals negative 3 plus or minus square root of 9 plus negative 4 times negative 9 is positive 36 times 10 is 360. Divided by 2 times negative 9. This is a 9, by the way. It looks kind of like a 4. Ugh, now it's just ugly. Oh well. Negative 18. 9 times 2, negative 18. Okay. Now, let's add these together. So we get, I'm going to write over here, negative 3 plus or minus the square root of 369 over negative 18. Now, none of these match this, so there must be more simplifying we can do. So let's see if we can simplify the square root of 369. So the easiest way to figure that out is see if there's any perfect squares that go into 369. I'm going to start by seeing if 9 goes into 369. It does. So that was a good guess. Okay, so 9 goes into 369 41 times. In other words, 9 times 41 is 369. And I'm going to use that to simplify. So I have negative 3 plus or minus 9 is a perfect square. It's 3 squared, right? So I can pull a 3 out of my square root. So 3 square root of 41 over negative 18. Now everything is divisible by 3. Notice that I've got negative 3, 3, negative 18. They're all divisible by 3. So I can divide everything by 3. I get negative 1 plus or minus the square root of 41 over negative 6. That matches this one. So the point of all of this is that if this doesn't match any of these, then there's probably some simplifying you can do in your radical. So you can simplify your radical, and then you'll be able to divide something. So the answer is D again. And that's it. And then, yes, this is the same thing. You just keep doing that over and over again. Okay, so hopefully that helps. Let me know if you have any questions. Sorry this video is so long, and I will see you guys later.